Good day. Welcome back. I'm sure you're enjoying learning the embedded system on ARM Cortex M4 programming so far. If you haven't revised the previous days, please do go back to them and revise them so that you would be able to be more familiarize yourself with usage of the different registers and the peripherals that's associated with it, and also the bus that's connected to the microcontroller. Today we are on day 28. Welcome back. Today we're going to learn our major project, the first project. It is going to be a Bluetooth based home automation. Yes, there is plenty of home automation projects out there through Bluetooth, but I'm just giving you the essentials so you would be able to do your own projects and you would be able to control your home appliances. Today we're going to control just one, controlling a fan, DC fan, but you can also have multiple devices to be able to control through an app. Yes, you can use it on the Android phone, or you can have an iPhone, iOS. So you can have the app, and you're going to send command from your app, and you're going to control the fan operation. So this is the section you're going to learn today. It's a Bluetooth home automation, and you're going to interface that with our STM32F411RE that we have been studying so far. I'm sure you will get plenty out of it by the end of the session, and also it will encourage you to come up with your own unique project, and I'm sure you can also use this in your own home or wherever you are. Before jumping in to show the major project line by line and starting you from scratch, I would like to introduce whom I'm representing from. I'm representing A2DG. It is a startup by Anbukarasu brothers, my brother Alex and myself Arul in 2023. Both of us gathered industry experience over 20 years, and we would really like to put it out there so that it would be all useful and helpful for you to shape you into a better professional and hopefully to your better rewarding career. On our mission is to convey our knowledge and our experience to at least 100,000 future professionals through our online courses. And the main advantage is you can study at your own pace wherever you are and wherever you are at the moment. So that is really good about that. A little bit about me. I'm Arul P. Anbukarasu. You can call me as Arul or API, as persistent as I would like to be to share my knowledge and my experience to you all. I have 20 plus years experience working in various industries in different countries in Australia, Italy, Singapore, and in India. In all these industries, renewable energy sector that has the solar and wind energy conversion, power systems that's lead associated with the lead acid batteries, network embedded systems that's connected with the ATMs, TCRs, and POS, banking automation systems, and smart parking operations. My expertise lies within these three domains: embedded systems, VLSI, and project management. A small announcement to make: all these video sessions will be uploaded into A2DG YouTube channel, so please do go through that. And in order to be eligible to get a free certificate, you have to watch the videos at least for 28 days. And at the end of each and every video, there will be an attendance link. Please click on that and fill in your details and send it across to us so that it will be eligible for your e-certificate. And part of YouTube regulations, the videos unfortunately can't stay there forever. It has to be removed after 2 or 3 days. So in case if you have missed a session and if you want to go back to revise it, unfortunately, you won't be able to. That's why I humbly request you and recommend you to join in one of our internship program. The internship professionals will acquire you to get an internship certificate, and that is worth a lot when you compare to the other engineers. And also when you go to that interview or after you got that first job working with the senior engineers, these journey that you had with us and also you learned for yourself about knowing all about this microcontroller will weigh a lot in the real-time industry. So the managers and the senior engineers will count this a lot, and you will be up and running from day one. So you don't need any prior introduction to the project. So that's why please to join our internship program. Not only that, you will get your own self login, so you can log into our LMS portal, learning management system portal. So you can go through our videos session by session. Once you finish one, if you click on complete, that will count your attendance. On top of that, you can also get unlimited access to all the course contents. That includes all the PDF materials, the study contents of the data sheet, the reference manuals, schematics, whatever you needed. And also, you will get unlimited access to all the course videos. So you could pause the video, you could go back and do something and come back and rewatch it. Or if you want to go back and revise past lessons, you can do so. And also, if you get stuck anywhere in the middle, please to contact our backend support team, and they would be able to help you with your learning journey. So shall we get into do our major project? I'm really keen, and I'm sure you are as well. So let's get in and start with our project. It is a Bluetooth based home automation. You would be hearing this word about the automation. So just to give a small cap, automation is nothing but to give you a operation in a form of less procedural way. So within your palm of a touch screen, you would be able to control things. So that's basically it. And we're going to control and interface that with a Bluetooth module. So you're going to interface the Bluetooth module with your STM32F411, and that's connected to the app. So you can control the app, and today we're going to learn how to control the fan through the app. These are all the hardware requirements. As you know, you need the nuclear board, STM32F411, a small DC fan, a 9 volt or a 12 volt battery, a HC05, that's a Bluetooth module, and a relay module to control. This is the picture shown is a 2 relay channel module. I'm going to use only one channel, so I got one channel relay module which I will connect through. And also you will see the output on the waveforms on the logic analyzer. So you need one logic analyzer as well. And of course your mobile phone, so be it Android or your iOS, your Apple phone. So these are all the hardware requirements. And the software requirements are you need to have the IDE, STM32Cube. I'm sure by now you all downloaded and you're practicing yourselves. And also any logic analyzer, but Salia is the really popular one, so please purchase that. And also the Android Bluetooth controller app from Play Store. Before jumping in, I would like to point out the advantages and disadvantages of using a Bluetooth. The advantages are Bluetooth are interoperable, meaning it can be connected to multiple devices at the same time. So that's why it's interoperable. But in terms of when you compare that to the infrared need to have a direct line of sight. In other words, it needs to communicate in a direct line, otherwise you can't send the data. But in Bluetooth, you can. The limitation is it can only be really efficient and operable in 10 meters distance. It can go in some stage 100 meters, but that's very high advanced Bluetooth, but 10 meters is the optimum. Whereas if you also compare with the wireless LAN as well, it consumes very less power. So these are all the advantages, and the disadvantages is it can only run up to the speed of 1 megabits per second. Whereas if you compare with the infrared, it's a little bit faster, and also the Bluetooth is much cheaper compared to the infrared and the wireless LAN. Wireless LAN, as you know, it's much faster. So the limitation of the Bluetooth is it's for shorter distance, and the speed also limited compared to the other protocols of infrared and wireless LAN. But Bluetooth is very essential. And you would see Bluetooth in every appliances wherever you are using. For instance, in your automotive industry, when you travel in a car, you can connect via your Bluetooth music. You can play in your car audio systems, and also through Bluetooth you can transfer data between mobile to mobile. So Bluetooth is really out there, and I'm sure by the end of this session you would be able to have a go at your own project, and Bluetooth is the one to go for. Let's get into the schematic design of our project, what it's going to be. We're going to use port B and port A for our project. So we're going to use USART1. So we need only, as if you remember, we need only three lines in the USART, that transmitter pin and the receiver pin on the ground. And the relay will be connected using port F5. So when I say PB6, that means it's port B pin 6. That's connected to the transmitter of the Bluetooth. And PB7 is port B pin 7. That's the receiver pin from the microcontroller, and that's connected to the Bluetooth transmit to the pin 4. And the relay is connected to the GPIO port on PF5. So this is the basic schematic design about this project. By default, the Bluetooth module will come in all these default settings. Default Bluetooth name, whenever you go and enable the mobile device, when you turn on the Bluetooth, you will see this name HC-05. And the default passwords are, sometimes it will be 1234, it will let you to connect. Sometimes it's 40, so you need to configure that. And the default communication is through slave mode. Default mode is data mode, and the default data baud rate is 9600, but you can also use in different baud rates. The command mode can be sent in 38400 with the 8-bit command mode. So these are all the default settings that it comes up with. And let's see briefly about the technical specification. Technical specification includes, it's a serial Bluetooth module, so therefore it can be interfaced, and you can also send your AT commands through your serial command, your hyperterminal, and you can communicate through that way. The operating voltage is typically from 4 volts to 6 volts in the range, but typically in our project we'll be using 5 volts, and the operating current is 30 milliamps. The range is less than 100 meters. So that's general specification. It works with mainly serial communication as a UART and TTL compatible. TTL compatible is 0 to 5 volts logic. And also supports the IEEE standardized protocol 802.15.1. And also this Bluetooth can operate either as a master or as a slave. And also you can easily interface this with all your computers, your laptop or your mobile phones. And it supports generally all the standard baud rate. We're going to use 9600, but it can also be operable at 19200, 38400, so forth. So far we covered up what Bluetooth is and all the specifications. I want to just give you a small introduction about relay. So most of you would be knowing by now what a relay does. It's nothing but, relay in a nutshell is nothing but it's a, if you like, you can use it as a device, or you can call it as a device. It's to control your AC input to operate a DC output. So that's a nutshell. So a relay is an electrically operated switch. It can act like a switch, on-off switch, to control certain devices. It consists of a set of input terminals, like these input terminals, for a single or multiple control signals, and a set of operating contact terminals. That's the contact terminals. And when it comes in two different operations, normally open and normally closed. So the traditional form of a relay uses an electromagnet to close or open the contacts, but other operating principles have been invented since then, such as the different types of the solid state relays, where there is no mechanical parts, but there will be conduction when it happens. So in order to control a certain part of your from AC, you can't do so because we are working on a low voltage system. So when you connect to the AC, like for example, the fan that we're going to learn, I'm going to only show today the DC fan, but you can use it in your home automation. Your fans, your lamps, your lights, whatever the device output is, has to be fed via a relay which controls those extra voltage and converts to give you the voltage that needs to control for that lamp or for that fan. So that's where the relay is. So whenever there is a volt goes through, the switch will be closed. So therefore this electromagnet or this coil will be energized, and there will be a current flow through this, and that current flow will act as an output for the control purpose for that device, whatever it's connected. So it will be normally open. So whenever you feed the 5 volts or 12 volts, whatever relay you're going to use, whenever you feed that input voltage, then the relay, the coil of that gets energized and sends it to the output. So this is how a relay is operated. Now let's briefly see about the block diagram. This is the block diagram to connect multiple devices, but we're going to see only how to control the fan. So through those Bluetooth pins, you're going to interface and connect that to the STM32F411. From the STM32F411, you're going to connect a logic analyzer as well, and also you're going to connect that to a relay, and the relay output is connected to a fan, so you can control those operations. Likewise, you can also able to control the light in the room, and also these days there is plenty of other gadgets that are in there, like for example electronic kettle in the kitchen, you can operate through Bluetooth, and so forth. There are some Bluetooth connected oven, so you can set your timings and operate that wise. So these are all just an example, so but this is the basic fundamentals. So if you know this to program and control, then you can make your own unique product, or you can make your own unique project, and you can work from there. So to control, I'm going to use two serial data, as if I type A in my serial terminal, it means the fan will be turned on, and any other data, any other character if I type, then that means the fan will be turned off. So that's how we're going to learn today. So these two are the serial data. And these are all the UART parameters. The baud rate will be 9600. There are also other baud rates, 96-200, 115-200, and also number of data bits as you would be covered in the UART parameters. So these are all the general UART parameters. And these are all the connection details. We're going to use PB6 and PB7. PB6 and PB7, so that's connected to the UART 1 TX and UART 1 RX, so the alternating function is 07. So you're going to use PB7, that's here, pin 21, and PB6 is here, that's pin 17. So pin 17 and pin 21 are used, and PA5, if you come here, that's pin 11, that's where the relay is connected to the PA5. So these are all the pins that you will be using it, and you're going to see that in the program and when I start to show you the program. So these are all the connection details. And this we covered in the UART transmit. So these are all the steps. I just copied from that. I haven't modified. So we are not using PA2, PA3, just to give you an example. We are using PB6 and PB7. Instead of PA2 and PA3, we're using PB6 and PB7. In the UART, we used UART 2, but here we're going to use UART 1. So that's only the difference. And these are all the UART transmit steps. And this is the block diagram. So we're going to use GPIO port A, and we're going to use UART 1. So the UART 1 is connected to the advanced peripheral bus 2. And GPIO port A is connected via the AHB bus. So you got to enable two clocks, AHB1 ENR and APB2 ENR. You need to enable those two. And these are the functional mapping, as I just briefly set, we're going to use PB6 and 7 because we are using USART1, TX and RX. You can also use PB3, but for more convenience, this is the receive pin. For more convenience, I'm taking PB6 and PB7 for functional mapping. And if you relate to that, the alternate function is 0, 7. So that's what we're going to program with. And also to just to list you, you can also use USART2, all this. But we're going to use USART1, so that's why those two pins are used, PB6 and PB7. And as you know, the alternate function F07, so you need to write 0111. This is shown as an example for PA2, but we're going to use PB6 and 7, which would be here, PB6 and 7. So you need to use bits 31, 30, 29, 28 as 0111. So bit 31 will be 0, bit 30, 29 and 28 will be 1. And likewise PB7, that is PB7, this is PB6. Bit 27 will be 0 and bit 26, 25 and 24 will be 1 to represent the alternate function. And this is the baud rate calculation you already learned in the USART. So this is the peripheral clock we're going to use with STM32, it's 16 megahertz. And the baud rate we're going to use is 9600. If you want to calculate the baud rate value, so you're going to put this in this formula and you'll get a baud rate register value of 1667. And if you convert that to hex, comes as 0 cross 068, 0683 is the hex value of 1667. This is what you're going to feed in the program as your baud rate, which you will see when when we write the code. And this is small snippets from the USART2 that we used to write the data and which registers that we're going to use accordingly. And we're going to use USART data register, as you know from previous sessions. And this is the connection details to a recap again. So PB6 is connected to the Bluetooth module transmit, and PB7 of RX on the microcontroller is connected to the Bluetooth TX, and from microcontroller PFI it's connected to the relay. Okay, so I will give you a couple of minutes break, so go and enjoy that break. When you come back, I'll show you line by line demo. We're going to write on STM32Cube IDE, and we'll go from there, and you will see the output in the logic analyzer, and also you will see the fan operation. So go and enjoy that break. I will see you in a couple of minutes. I'll see you shortly. Go and enjoy that break. See you then.